It is 5:30 in the morning, somewhere in California's Central Valley. The year is 1929. A man stands next to a machine that weighs more than a loaded freight wagon, waiting. He has been waiting for almost an hour. The steam tractor beside him is cold iron. Its boiler sits empty of pressure, its firebox dark. Before this machine will move a single inch of earth today, the operator and his firemen will need to light the fire and slowly build heat to avoid cracking the boiler plates, raise pressure to 150 pounds per square inch, and check every fitting, every gauge, every relief valve. The whole process takes anywhere from 1 to 3 hours, depending on conditions. If the temperature dropped below freezing overnight, add another hour. The water in the boiler may have turned to ice. And water is the real problem. This steam tractor will consume roughly 2,000 gallons today. Its onboard tank holds maybe 300 gallons. A dedicated water wagon and driver will make trip after trip to the nearest creek or irrigation ditch, burning fuel and labor just to keep the boiler fed. If the water source dries up or freezes, the machine sits dead. The fireman will spend his entire shift standing feet from a firebox that reaches nearly 2,000 degrees Fahrenheit. Sources from the era describe it as drenching the fireman in his own sweat, conditions that reminded workers of something considerably warmer than a California morning. And there is the danger that nobody talks about until it happens. Steam boiler explosions. In 1917 alone, the Hartford Steam Boiler Inspection Company documented 506 boiler explosions across the United States. 149 people were killed. 289 were injured in a single year. As little as 50 pounds of pressure per square inch carries the explosive force of black powder. A full working boiler at 150 pounds per square inch is a bomb waiting for a cracked plate, a corroded crown sheet, or a stuck safety valve. As recently as 2001, a steam traction engine exploded at the Medina County Fairgrounds in Ohio, killing 5 people and injuring 49. The crown sheet had corroded and thinned by 77%. Nobody had noticed. This was the world of construction in the late 1920s. Brutal startup times, catastrophic water consumption, mandatory 2-man crews, and the ever-present risk of a boiler turning into a fragmentation bomb. There was a better way. Everybody in the industry knew it. The diesel engine had existed since 1892. It was 2.5 times more efficient than steam. It burned cheap fuel. It needed no boiler, no fireman, no water wagon. But nobody could figure out how to put one in a tractor. The man who finally solved that problem was not an engineer. He was a tractor company chairman named C.L. Best, and the gamble he made during the worst economic collapse in American history would kill the steam engine, bankrupt his competitors, and build the largest diesel engine manufacturer the world has ever seen. This is the story of how 157 machines changed construction forever. To understand why diesel took 39 years to reach a tractor, we need to start with the man who invented it and the mystery surrounding his death. Rudolf Diesel filed his German patent on February 28, 1892. His American patent, patent number 5428846, followed that August. The core insight was compression ignition. Instead of using a spark plug to ignite fuel like a gasoline engine, Diesel's design compressed air so intensely that it heated to the point where injected fuel ignited spontaneously. The thermal efficiency was roughly 26%, compared to about 10% for the best steam engines. That meant his engine extracted more than twice the useful work from every unit of fuel burned. His first experimental model, built at Maschinenfabrik Augsburg in Germany with financial backing from the Krupp Steel dynasty, exploded on its very first test run in 1893. Diesel was nearly killed, but the explosion actually proved the principle. Compression alone could ignite fuel. By 1897, a working 25 horsepower single-cylinder diesel engine ran successfully at 154 revolutions per minute. Here is a detail about Rudolf Diesel that almost nobody knows. At the 1900 World Exhibition in Paris, he demonstrated his engine running on peanut oil, not diesel fuel. Peanut oil. He was arguably the first advocate of what we now call biodiesel, more than a century before it became a mainstream concept. Thomas Edison reportedly called the diesel engine one of the great achievements of mankind. But Diesel never saw his invention reach mobile equipment. On the night of September 29, 1913, he boarded the SS Dresden, a steamer leaving Antwerp for Harwich, England. He was traveling to the groundbreaking of a new diesel manufacturing plant and a meeting with the British Royal Navy about powering their submarines with his engines. He dined with 2 colleagues that evening, retired to his cabin at 10 o'clock, and left instructions to be woken at 6:15 the next morning. His cabin was empty. The bed had not been slept in. His nightshirt was neatly laid out. His watch had been placed where it could be seen from the bed. His hat and folded overcoat were found beneath the afterdeck railing. In a diary he brought aboard, a cross had been drawn next to the date September 29. Before leaving Antwerp, he had given his wife Martha a bag with instructions not to open it for a week. Inside were 20,000 German marks in cash, and financial statements showing their accounts were nearly empty. His body was recovered by a Dutch pilot boat near the mouth of the Scheldt River on October 10. Personal effects were identified by his son 3 days later. Whether it was suicide driven by financial ruin, assassination by German intelligence agents furious about his negotiations with the Royal Navy, or murder by coal industrialists who saw his engine as an existential threat remains debated to this day. Rudolf Diesel was 55 years old. For the next 18 years after Diesel's death, his engine remained imprisoned in stationary installations and ship engine rooms. The problem was brutally simple. Diesel engines of that era were enormous cast iron machines designed to sit on concrete foundations or ship keels. They used AIR blast fuel injection systems that required separate high-pressure compressors, adding massive weight and complexity. They ran at barely 250 revolutions per minute. The slightest vibration, dust contamination, or shock loading could crack castings and destroy precision components. Construction and agricultural environments offered all 3 of those killers simultaneously. Closing the gap between Rudolf Diesel's stationary engine and a working crawler tractor would require a man who grew up surrounded by heavy iron and high-pressure steam. Clarence Leo Best was born April 21, 1878, in Albany, Oregon. His father, Daniel Best, was a prolific inventor who held 41 patents and built some of the largest steam traction engines of his era, reaching 110 horsepower. Daniel Best's machines featured a distinctive upright boiler that operated at 200 pounds per square inch, 50 more than most competitors, with a design that kept water directly above the firebox to prevent the catastrophic crown sheet failures that caused so many boiler explosions. C.L. Best grew up in his father's factories. By 1910, he had founded his own company, the C.L. Best Gas Traction Company, near San Leandro, California. He was a direct competitor to the Holt Manufacturing Company, which had purchased part of his father's business. While Benjamin Holt focused on military contracts during World War I, supplying roughly 10,000 tracked vehicles to the Allied forces, Best captured the domestic market with superior tractor designs. He was called the Henry Ford of the track-type tractor. The pivotal moment came in 1915 at the Panama-Pacific International Exposition in San Francisco. Best saw large stationary diesel engines on display and conceived the idea of putting diesel power into a tractor. The technology was not ready. American diesels of that era were enormous brutes designed for concrete floors. But the idea lodged in his mind and stayed there. On April 15, 1925, Best's company merged with Holt Manufacturing to form the Caterpillar Tractor Company. Despite Holt's greater name recognition, Best effectively controlled the merged entity. He became chairman of the board, a position he held for 26 years until his death in 1951. Benjamin Holt himself had died in December 1920, 5 years before the merger that carried his company's name into history. If you are enjoying this deep dive into Caterpillar history, hit like and subscribe. We cover construction equipment history and industrial disasters every week. Now here is where the story takes an unexpected turn. The most dramatic catalyst for Caterpillar's diesel program came not from inside the company, but from an outsider who refused to take no for an answer. In the late 1920s, contractor Henry J. Kaiser directly asked Caterpillar to install diesel engines in their crawler tractors. Diesel fuel was cheaper, and Kaiser wanted the savings. Caterpillar declined. The Holt side of the merged company was not interested in diesel engines. Kaiser did what Kaiser always did. He went around them. He purchased 3 Caterpillar Model 60 tractors and 3 Monarch 75 tractors, then ripped out their gasoline engines and replaced them with 65 horsepower marine diesels manufactured by Atlas Imperial Engine Company of Oakland, California. Atlas Imperial had been building marine diesels since 1919 for tugboats and fishing vessels. Kaiser put his converted machines to work on a Mississippi River levee restoration project. The results were spectacular failures. A 1942 Life magazine profile recorded that at first, they stripped transmissions, twisted drive shafts, and generally knocked apart the machines. The marine engines were heavier than gasoline engines. They produced torque in violent shock loads the drivetrains were never designed to handle. They had no protection against the dust, vibration, and constant jolting of crawler tracks over rough ground. At least one of Kaiser's bootleg Atlas Imperial conversions survives today, serial number 3686A, having passed through the Heydrich collection in Woodland, California, before reaching a private collector in England. Kaiser's failures demonstrated 2 things at once: the overwhelming economic demand for diesel in tractors, and the absolute impossibility of simply dropping an existing diesel engine into one. This was the proof C.L. Best needed to authorize Caterpillar's own purpose-built diesel program, and to hire the right engineer to lead it. In 1928, Caterpillar brought on Carl George Arthur Rosen as Chief Diesel Development Engineer. Rosen brought exactly the expertise this project demanded. He had served as chief engineer at Dow Pump and Diesel Engine Company from 1915 to 1922, and at Pacific Diesel Engine Company from 1923 to 1924. He understood marine diesels intimately, and he understood why they failed in tractors. Rosen's team worked at Caterpillar's engineering laboratory in San Leandro, California, Best's old factory. The list of problems they faced reads like an engineering textbook of impossibilities. Every diesel engine on the market used air blast fuel injection, which required a separate compressor that added enormous weight and limited engine speed to about 250 revolutions per minute. Dust from agricultural and construction sites would destroy cylinder walls, pistons, and bearings within weeks. Shock loading from tracks running over uneven ground would crack engine castings designed for stationary use. And there was no practical way to start a large diesel engine in the field. The fuel injection pump alone required machining tolerances of 25 millionths of an inch and had to hold 1,800 pounds of pressure for 6 minutes. No production machinery could achieve this. Rosen's team had to design and build the testing equipment before they could design the engine itself. On June 28, 1930, after 2 years of development, the team assembled Old Betsy, the D9900 prototype diesel engine, serial number 1A14. It was a 4-cylinder inline diesel with a 6 1/8 inch bore and a 9 1/4 inch stroke, displacing 1,090 cubic inches, which is nearly 18 liters. It produced 87 horsepower at 700 revolutions per minute. Rosen's critical breakthrough was the pre-combustion chamber design. Instead of blasting fuel directly into the cylinder with compressed air, his system injected fuel into a small antechamber where initial combustion began. Then the gases expanded into the main cylinder. This eliminated the cumbersome air compressor entirely. It allowed lower injection pressures, smoother combustion, and far better cold weather starting. His other stroke of genius was the gasoline pony motor starting system. A small two-cylinder gasoline engine mounted directly on the diesel. The operator hand cranked the pony motor to life, which then mechanically turned the diesel through a pinion gear engaging the flywheel. The pony motor was plumbed into the diesel's cooling system, so while it idled, it preheated the diesel's coolant. Its exhaust was ducted through the diesel's intake manifold to warm it. This integrated preconditioning system solved diesel's most stubborn problem: reliable, cold weather starting, and became standard on every Caterpillar diesel for more than 35 years. Old Betsy underwent over 16 months of brutal testing on a reinforced Caterpillar 60 chassis. The total investment exceeded $1 million, roughly 18 to 20 million in today's money. It was spent during the depths of the Great Depression, while Caterpillar's annual sales were collapsing from $45 million in 1930 to just $13 million in 1932. Holt-Best bet his company on this engine. In September 1931, the bet paid off. The first production Diesel 60, serial number 1C1, rolled off the assembly line at Caterpillar's Stockton, California plant. This factory traced its origins back to 1883, when Benjamin Holt and his brother Charles founded the Stockton Wheel Company. On Thanksgiving Day, 1904, Holt had tested his first successful tracked steam tractor outside that same factory. A photographer watching the tracks grip the soft delta soil reportedly said it crawls along like a caterpillar. The name stuck. Only the first two production units, 1C1 and 1C2, were built at Stockton and painted in the old battleship gray color scheme. The remaining 155 machines were manufactured at Caterpillar's Peoria, Illinois plant and painted in the new highway yellow. Total production of the Diesel 60 came to just 157 units, serial numbers 1C1 through 1C157, built between August 1, 1931 and December 30, 1932. The machine weighed 24,390 pounds, nearly 2 tons heavier than the gasoline 60 it replaced. The frame rails were extended and strengthened. Cast components replaced fabricated steel in critical load-bearing areas. A heavier, geared-down transmission handled the diesel's massive low-end torque. The fuel tank held 75 gallons. When the Diesel 60 arrived at the University of Nebraska for official testing in June 1932, it made history before the test even began. Test number 208 was the first diesel tractor ever evaluated under the Nebraska Tractor Test Law. When the machine arrived, commercial diesel fuel was so scarce in Lincoln, Nebraska, that they had to run the test on number 2 furnace oil instead. Now let us talk about what made this machine lethal to every competitor in the industry. Like and subscribe if you are enjoying this. Look at the machine that changed everything. The economics were devastating. Diesel fuel in the early 1930s cost roughly 8 to 10 cents per gallon. Gasoline ran 17 to 20 cents per gallon. The diesel engine consumed approximately half the fuel of a comparable gasoline engine for equivalent work. The compounding effect meant diesel fuel costs ran to roughly 1/4 of gasoline costs per unit of work delivered. Against steam, the gap was even wider. A 25-horsepower case steam engine consumed 1 ton of coal and approximately 1,700 gallons of water in a single 10-hour operating day. A diesel tractor burned a fraction of that cost in fuel and needed 0 water for the engine. Labor savings were just as crushing. Steam required a minimum of 2 men, an operator and a licensed fireman. Some steam operations ran with 7-man crews. A diesel tractor needed 1 operator. That cut labor costs by 1/3 to 1/2 overnight. Startup time sealed the verdict. 1 to 3 hours for steam, 5 to 15 minutes for a diesel with a pony motor. Every morning, across every construction site in the country, diesel operators were moving dirt while steam crews were still building pressure. At Fort Peck Dam in Montana, one of the largest New Deal projects in America, the 8th and 13th Diesel 60s off the assembly line built roads and hauled graders. Their first-year operating cost was checked against 2 competitive gasoline tractors. The reported savings was $3,000 per machine. On that single project, there were 21 Caterpillar machines for every one from all other manufacturers combined. 10 of the first 25 Diesel 60s were shipped to Belgium for the King Albert Canal project, an 80-mile waterway connecting Antwerp to Liege. Those machines worked daily for 9 straight years during the canal's construction, from 1930 to 1939. 12 Caterpillar 60 tractors also worked on the Hoover Dam, building diversion tunnels, hauling pipe, and working 800 feet above the Colorado River. In the 1930s, 92% of track-type tractors on major American construction projects were Caterpillars. Serial number 1C12 earned the nickname Old Tusko, almost certainly named after Tusko the elephant, a 7-ton Asian bull who was a Pacific Northwest celebrity at the time, billed as the biggest beast that walks the earth. Old Tusko the tractor set a world record for both continuous running time and fuel economy during a non-stop plowing endurance test in 1932. On December 7, 1931, the same month the Diesel 60 was entering production, Caterpillar made another decision that would define the industry for the next century. Every single Caterpillar product changed from battleship gray with red trim to highway yellow with black trim, all at once, in a single day. The initiative came from Ollie Sleater, who had been in charge of painting and hand lettering Caterpillar tractors since 1917. By 1931, Caterpillar had expanded heavily into road construction machinery. Unlike sparsely populated farm fields, highway construction sites were crowded with workers, trucks, and moving equipment. The company needed a color visible at the greatest distance both day and night, yet still pleasing to the eye. Tests narrowed the options to 3 finalists: a shady yellow, a flash red, and white. Yellow won. The name Highway Yellow was a direct nod to highway construction. Rumors circulated that some dealers secretly repainted their machines gray, fearing customers would not buy yellow equipment. They were wrong. Highway Yellow lasted 48 years until June 1979. The competitive shockwave from the Diesel 60 took nearly a decade to resolve. International Harvester responded fastest, producing the McCormick Deering TD40 diesel crawler in 1932. But their gas start system was less elegant than Caterpillar's pony motor, and they did not complete a full diesel crawler lineup until the TD18 arrived in October 1938, 7 years behind. Cleveland Tractor Company, Cletrac, followed in 1933 with the Model 80D. Cletrac survived the Depression partly through Civilian Conservation Corps contracts, but was ultimately sold to Oliver Corporation in 1944. Allis-Chalmers fumbled badly. In 1935, they tried an interim solution, the Hesselman-Waukesha oil engine. It was a Swedish semi-diesel hybrid using spark plugs with direct fuel injection at low compression. About 50 crawlers were built with this engine. The results were terrible: incomplete combustion, fouled spark plugs, and extremely heavy toxic exhaust smoke. Allis-Chalmers did not produce a true diesel crawler until the HD-14 in 1940, fully 9 years behind Caterpillar. They had to use General Motors' Detroit diesel engines because they had no diesel design of their own. John Deere, committed to their signature 2-cylinder gasoline engines, did not enter the diesel crawler market at all during the 1930s. Their first diesel tractor, the wheeled Model R, arrived in 1949, 18 years after the Diesel 60. Steam's extinction followed a clear timeline. Peak steam in construction occurred around 1911 and 1912. By the mid-1920s, steam agricultural tractors were largely gone, replaced by gasoline. The Diesel 60 and its imitators pushed diesel into the gap gasoline had opened, and by the late 1930s, no manufacturer was selling new steam construction equipment. Surviving steam machines ran out their useful lives on older projects through the 1940s. One of the last known commercial steam shovels, a Bucyrus Erie 50B, operated in a mine near Nederland, Colorado, until 1978. One of the least known consequences of the Diesel 60 program had nothing to do with tractors. By 1933, with roughly 1,000 Caterpillar diesels in the field, a severe problem emerged. Piston rings were seizing after as few as 300 hours of operation. Oxidized lubricant turned gummy, mixing with carbon to create a destructive paste that scored cylinder walls and burned bearings. Art Rosen launched an in-house lubricant research program and contacted Standard Oil Company of California, located just 20 miles from the San Leandro lab. There, research engineer George Leonard Neely had been independently investigating the same problem using a small bench test engine. He discovered that aluminum dinaphthenate could prevent and even reverse ring sticking. When Neely offered experimental oil to Rosen, Rosen reportedly had a truck on the way to Standard Oil before the phone line cooled off. Together, they developed a standardized diesel lubricant testing protocol. In 1935, their joint work produced a new motor oil branded DELO, which stood for Diesel Engine Lubricating Oil. It was the world's first detergent motor oil. DELO went on to pioneer multigrade oil in the 1950s, ashless detergent oil in 1957, and is still sold by Chevron today in 155 countries. Without the field failures of the Diesel 60 forcing Rosen and Neely together, the modern lubricant industry as we know it would not exist. Like and subscribe for more stories about the machines that built the modern world. Old Betsy, the D9900 prototype, had one final chapter. After the San Leandro lab relocated to East Peoria, Illinois in 1938, team member Charlie Schad crated the engine and put it in storage. In the mid-1960s, Schad pulled Old Betsy out, repainted her, and placed her on display at the Caterpillar Technical Center in Mossville, Illinois. As Schad approached retirement around 1972, engineers decided to honor him by running Old Betsy through the newly required state and federal emissions and smoke tests. Art Rosen, by then in his 80s, traveled from California to witness the occasion. To everyone's amazement, 42 years after she was hand-assembled in San Leandro, Old Betsy passed with flying colors. On November 29, 1973, Old Betsy was formally donated to the Smithsonian's National Museum of American History. The museum recognized her as being of significant historical importance, the first mass-produced diesel engine ever made in the United States. The engine was later loaned to the Peoria Riverfront Museum in 2012, where she sits today near the Caterpillar Visitors Center. There is one more thread that connects the Diesel 60 to world history in a way almost nobody discusses. During the early 1930s, Soviet purchasing agents ordered more than 1,350 Caterpillar track-type tractors for Stalin's collective farms. These orders helped keep Caterpillar financially alive through its worst year. a $1.6 million loss in 1932. The Soviets then did what the Soviets always did. They reverse-engineered the Caterpillar 60 at the Chelyabinsk tractor factory and began producing their own copy, the Stalinets S-60, starting June 1, 1933. Over 100,000 S-60 and S-65 tractors were built between 1933 and 1941. When Germany invaded the Soviet Union, those same Caterpillar copies served as artillery prime movers for the Red Army. A machine designed for California farmland ended up hauling guns on the Eastern Front. The Diesel 60's direct lineage tells the rest of the story. Diesel 60 became Diesel 65. Diesel 65 became Diesel 70. Diesel 70 became the RD8, and the RD8 became the D8, one of the most iconic pieces of construction equipment ever manufactured. Between 1942 and 1945, Caterpillar produced over 56,000 crawler tractors for the Allied war effort, including more than 20,000 D7 units, direct descendants of the Diesel 60's engineering, which built airfields across the Pacific with the Navy Seabees. By the end of the 1930s, more than a third of Caterpillar's total revenue came from selling diesel engines to other equipment manufacturers. The D17000 engine that succeeded the D9900 remained in production for nearly 50 years. What Best saw at a San Francisco World's Fair in 1915, what Kaiser proved with his bootleg conversions, what Rosen engineered in a San Leandro workshop, and what 157 yellow machines demonstrated on construction sites from Montana to Belgium, all traces back to Rudolf Diesel's compression ignition insight of 1892 and the stubborn conviction of one company chairman who, in the middle of America's worst economic catastrophe, spent $1 million on a bet that a new kind of engine could replace steam, replace gasoline, and remake an industry. He was right, and construction was never the same again. If you want to see how Caterpillar's crawler track design changed construction even before diesel arrived, that video is on screen now. Like and subscribe for more construction legends.